So I'm going to be presenting a brief overview of our project. I'm not going to go into too much detail for the sake of time, but I'd encourage you all to check out our blog. All the project details is there. My contact information is on the screen here, and if you want to contact me later on, I would be pleased to answer any questions. And I'd also encourage any questions that you have along the way. You can please feel free to answer them. So, okay, so my agenda today is to essentially go through the mission and goals of our project, basically what we plan to do, what our motivation was for undertaking the project. I want to talk a little bit about our value network, for whom we were creating the value for, who we believe our target customers are and end users are, and go into a little bit on our strategy, basically our approach to how we were going to deliver against the project, what resources we were going to use to essentially accomplish our mission. I'll take you through a live demo of our solution, and then we'll talk a little bit about next steps and basically where we see the project going from here. So in terms of a little bit of background, I'm in the home energy audit space, energy efficiency improvement business. And I'm very interested in the IoT space, and I have interest also in environmental issues. And I've been thinking about a way to help reduce carbon output, greenhouse gases using technology. And the bottom line is that we all produce too much carbon, according to the statistics. And there's simple things that I think we can do to help fix the problem. And so when the Open IoT challenge came along, we came up with the idea of the residential home diagnostic system. And really, I think our mission is to help reduce the carbon footprint using open source technology of our homes. And the idea here was really to create a smart energy IoT solution for performing home diagnostics. And the idea is essentially a do-it-yourself energy audit system using IoT methods and sensors. So we set out to reproduce the key metrics of a professional energy audit. And today, really, that's about the only way that you can really figure out what's going on in your homes in terms of energy use, is to bring in a professional. So the idea here was to allow homeowners or service organizations to basically peer into the energy use of a home and to do self-diagnostics and optimize that consumption. And we picked heating and cooling because heating and cooling typically accounts for about half the energy use in a home. And it's the largest expense, and so the idea is that if we can understand how much energy we use for heating and cooling, we can certainly reduce that through observation, and then of course reduce the carbon output of our homes. And so our targets are essentially who we're doing this for is homeowners, giving them the ability to self-diagnose energy consumption and thereby lower their carbon emission output. We also see value for service organizations like heating, ventilation, air conditioning companies, and energy audits, where they can, with the system, peer into a residence and help provide better care, customer care for that environment, and essentially reduce truck rolls, which is also good for an environment because they can diagnose over the internet using the cloud as a means to view the data. Then that's going to improve the performance and customer care. We also see a value for government agencies, where we give them also the ability to give them essentially visibility into residential carbon output so that they can judge and audit the value of their energy efficiency programs. In terms of our strategy, we had a development team of about, we had 3 people on the team. We had a little bit of product management, some software skills, some building science, and a little bit of electronics. In terms of the hardware, we based the system off a Raspberry Pi 2. We were using Texas Instruments sensor tags, 2650s, and basically it's kind of 9 sensors in one. And we used an NXP microcontroller to house our Lesion, not our Lesion server, but our Wakama client for doing device management. At the gateway level, software, we used Eclipse Cur as the gateway. For device management, we used Eclipse Lesion and Wakama. And database, we used MongoDB, and all those are, of course, pretty much open source technologies, are certainly open. In terms of protocols, we used MQTT it's a pub subsystem. It's a lightweight messaging protocol, and that provided the communications between the IoT gateway and the cloud service. We used lightweight M2M between as the connection between our Lesion server and Wakama endpoints. And we used BLE between the sensors and the Kura gateway, and then of course a little bit of Wi-Fi in there as well. In terms of services, we used on the front end Amazon Web Services. We used their IoT gateway component to receive the MQTT traffic. We housed our data in the DynamoDB, and then we used their API gateway to give us a REST interface, which then we connected to using Freeboard IO, which is again an open source dashboard service. In terms of our architecture, essentially the system is based on a Raspberry Pi 2, and the heart of the system really is the Kura gateway. Its primary job is to connect multiple TI sensor tags via BLE and packetize the sensor data into a JSON format, and then create an MQTT data stream back to the AWS for cloud storage. Kura's secondary responsibility is to push a copy of the sensor data in JSON format over to a Mongo database. We found it necessary to do data cleansing and processing of the raw sensor data before forwarding it to the cloud. Basically, it was easier and more cost-effective to process data locally versus trying to do it out in the cloud. And of course, our front-end application, as I mentioned earlier, is Freeboard, and it's serviced through the REST API from Amazon. I'm going to switch over now to our brief view of the product itself. I'll give you an idea of the dashboard. So what you're looking at here is the Freeboard application running, and this is a visual of all the sensor data that we're capturing. And again, the idea was, the goal was to be able to reproduce the key metrics of an energy audit. And the way we did that is the keys really were to be able to capture the internal environmental conditions and the external environmental conditions, and then use some building physics formulas to make some calculations. And then the goal was to be able to see if we could produce the same metrics as a energy audit, and we were able to do that. So essentially, the first thing we were able to do is reproduce the load profile of my home. And this is something that an energy auditor would come in to do a load calculation. And then this curve here, or this line, basically plots how much energy you need to heat and cool your home. And so using our formulas, we were able to reproduce that curve, and therefore we were able to make some further calculations. And so what we've got here is environmental data coming in from Environment Canada, and then we've got 4 sensors deployed throughout my home, and then we use formulas to essentially calculate how much BTUs my home is burning, and essentially the carbon output of my home, which is coming in at about 12.5 metric tons for my heating at this time. And then we're able to do some real-time calculations, so we can essentially do the same thing of calculating how many BTUs we're burning per hour in the carbon on a real-time basis. We're also able to calculate the air infiltration rate of my home, another key metric that's used by energy auditors to determine how energy efficient your home is. We're also tracking over here. Basically, it's a thermostat variation. It tracks how much temperature is swinging in the home. Eventually, it should be pretty tight. If it's too much of a swing, then your thermostat, of course, which is the control system of your home, isn't functioning properly, and this would identify that. And we're also able to pull in some humidity metrics to basically assess the comfortability of the home. And then we provided a little bit dashboard here, which has come in pretty handy a lot. This essentially just tells me if my data is coming in and it's being reported correctly. I find that the TI sensor tags are pretty hungry on the battery use, so these metrics here help me to keep up with replacing the batteries in the system. So essentially, that's the demo of the system itself, and I'll just switch quickly over to the final slide. Okay. So, okay, my last slide is essentially next steps. From here, what we want to do is validate and verify our results with government agencies to ensure that the data that we're producing is valid. And then on the technology side, we see ourselves doing a little bit more work with sensor efficiency. It says, as I mentioned earlier, the sensor tags that we're using right now are not exactly efficient. We'd like to find something that's a little bit more battery friendly. We want to do a little bit more on the historical reporting. So right now we have a live dashboard. We want to be able to allow the end user to basically look at history information. We want to go a little bit better UI. We want to tighten up our integration with our HVAC system, and we want to find a commercial cloud solution that's cost effective. In terms of use case, we see applications for smart cities, the smart grid, smart energy. Basically, it's just giving visibility into energy use and then applying that data for whether it's for renewables or for better just understanding what your energy use is or for lowering carbon output. We see applications for the HVAC industry to be able to provide them better service to their customers and basically reduce truck rolls. And education, I think, is a big one. We want to be able to provide real-time information for homeowners that you can use to better understand and learn about the impact of behavioral choices as it relates to heating and cooling. Presently, right now, the only way to do that is to send in an energy auditor, and so we're hoping the RDH system can be mass deployed and then allowing people to do it themselves, and then they become the experts. And if they need to call in the experts, they essentially have the means to, because everybody can see the data in the cloud. So essentially, that's my system. I apologize, I went over a little bit of time, but I hope you enjoyed the presentation. And if you have any questions, my contact information is here. And thank you.